Yeah, hello students. Welcome to Akshara IT Foundation. This is Syno, your maths faculty. Let us go to the today's class. Right. So we're in the problems of binomial expansion. So let us continue the problems in exercise problems. Okay. Right. So we already completed up to 8 problems, right? Yeah. So let us see the next problem. That is the sum of the coefficients of odd powers. Sum of the coefficients of odd powers in the expansion of 1 plus x square plus x cube whole to the power of 5. Okay, so this is the polynomial which is having a degree 5. Okay, so we need to find out the coefficient, sum of the coefficients of odd powers. Now you should remember here sum of coefficients odd powers. So before that, let us consider the given polynomial or given expansion or given this polynomial as f of x. Let us take the given polynomial as f of x, and sum of the coefficients of odd powers formula is f of 1 minus f of minus 1 by 2. So this is the formula for sum of coefficients of odd powers. Okay, so let us try to find out f of 1 value. F of 1 value is nothing but whenever you see the x term, we have to substitute 1 in the place of x. So this is 1 plus, in the place of x we should substitute 1. So 1 plus 1 x square is nothing but 1 square. 1 square value also 1, and x cube also nothing but 1, because 1 cube value is 1 whole to the power of 5 minus f of minus 1. So I am just substituting here f of minus 1. 1 is a constant term, as it is we can substitute, and plus in the place of x value substitute minus 1, plus into minus 1. Okay, again plus in the place of x minus 1 whole square, will be plus 1, and last x cube minus 1 whole cube. Whenever you have seen odd powers, the negative term will be remains as negative. When you see the even powers, the negative terms becomes a positive terms. Okay, so this will be negative 1 whole divided by 5 and whole to the power of 5 and divided by 2. Now 1 plus 1 plus 1 plus 1 nothing but 4 power 5 we can write, minus plus 1 minus 1 cancel, and here also plus 1 minus 1 cancel, 0 power 5, 0 power anything is 0, and the answer can be taken as 0 divided by 2. Now we have remains only 4 power 5. 4 power 5 is nothing but 4 should be multiplied by itself 5 times. So that is nothing but 4 into like 5 times you can write denominator 2, from one of them we can write divided by 2 times. Now 4 power 4, 4 4s are 16, 4 4s are 16, 16 16s are 256, 16 16s are 256 into 2, that is nothing but 512. So this is the value of sum of coefficients of odd powers. Whenever you are observing that sum of coefficients of even powers, we can take the formula f of 1 plus f of minus 1 by 2. Okay, na? So this is the answer for sum of coefficients of odd powers. Okay, that is 512. Okay, now let us go to the next problem. That is problem number 10. The coefficients of x square plus k by x whole to the power of 5. So therefore the expansion or the polynomial is given that x square plus k by x whole to the power of 5 is 270. So there is a small mistake in the question, that is you need to change that the coefficients of x. Coefficient of x is 270, then find the value of k. Okay, no? But here x is missing. If the coefficient of x in x square plus k by x whole to the power of 5 is 270, then k value we should find. Okay, no? So let us take to the general form for expansion or for finding the value of x coefficient. Now I am using the general form, that is nothing but TR plus 1 equals to NCR x power n minus r into y power r. This is the general form of binomial expansion. Okay, na? Here n is nothing but 5 and we don't know which term will gives the x coefficients. That's why I have remained the r value is like that and n value is 5cr. X is nothing but first term, that is x square. So in the place of x we should write x square whole to the power of n minus r. That means n value is 5 minus r into y power r. What is value of y? Y value is nothing but k by x whole power r. Okay, that equals to 5cr x power, that is it is in the form of this one in the form of a power m whole power n formula. A power m whole power n is nothing but a power m into n. So this one I can write 2 into 5 10 minus 2 into r is 2r. So this is the x power 10 minus 2r into this one. Also I am going to apply the power separately to the numerator and denominator. It will be k power r and denominator x power r. When you bring it to numerator, it will be x power minus r. Okay, now let us see, that is equals to 5cr x power. Now while you are observing again x and x with into symbols, if the bases are same with into symbol, we can add their exponent by using the law of exponent. A power m into a power n is equals to a power m plus n. By using this law of exponent, we can write this x power 10 minus 2r minus r is nothing but 10 minus 3r. 10 minus 3r into k power r. And from the question it is given that the coefficient of x value is 270. Coefficient of x. Only x is given, not x square, x cube, x power 5 is not mentioned about the powers, only x. X means the power should be 1. Am I right? Then x power 1 is nothing but x. So from that problem we know that the power of x must be 1. So 10 minus 3r equals to 1. So minus 3r equals to plus 10 transpose outside minus 10, 1 minus 10 is nothing but minus 9. So from this we can identify r value is 3. R value is 3. That means whenever the r value is 3, this x power 1, this x power will become 1. Then we need the coefficient. Then what is the remaining part of coefficient? Coefficient is nothing but 5cr except x remaining part, 5cr k power r. This is the coefficient of x, but we already found that r value is 3. So let us substitute, that is 5c3 k power 3. This value is already given, that is 270. Okay, now 5c3, 5c2 both are having the same values because of NCR equals to NC n minus r. We have discussed in our previous problems. Okay, so we can write this 5c2. 5c2 is nothing but 5 into 4 by 2 into 1 into k cube equals to 270. So 2 table in 4, 2 times 5 2 is 10. 10 transpose that side, it is going to be divided. So 270 by 10 is nothing but 27 times. And 27 is a cube number. Which cube? 27 is a 3 cube. So we can write k is equals to 3. Nothing but k cube value equals to 3 cube. Both cubes can be cancelled both sides. Then k value becomes 3. Okay, na? Let us go to the next problem. Yeah, the problem number 11 is given that in that expression x plus x power log of x to the base 10 whole to the power of 5. The given expression is given that x plus x power log of x to the base 10 whole to the power of 5. Okay. Now here the third term is 10 power 6. Then x value we need to find. Third term in this expansion will be 10 power 6 it seems. Okay, na? The given third term t3 equals to 10 power 6. Okay, na? T3 is nothing but T2 plus 1. So nothing but NCR. N value how much here? I am writing the general form here. TR plus 1 equals to NCR x power n minus r into y power r. So in the place of r we should take 2. That means NC2. That means 5C2. X value x only, x power 5 minus 2 and y value x power log x to the base 10 whole to the power of r. R value is 2. Okay, na? Now we know that this value is already given. This is 10 power 6. So T3 is nothing but 10 power 6. So left hand side we can write 10 power 6. Now coming to the 5C2. 5C2 is nothing but 5 into 4 by 2 into 1 into x cube. X power 5 minus 2 is nothing but 3. X cube, and here we can write this one x power log x square or 2 log x to the base 10. Okay, na? Yeah. Now 2 table here, 2 times 10. 5 2s are 10. When you transpose 10, it is going to divide. Then left hand side 10 power 6 by 10 power 1 is nothing but 10 power 5. Okay. So that is equals to, while you are observing here, the bases are same. We can add the exponents by using that x power 3 plus 2 log x to the base 10. 2 log x to the base 10. Clear? Right. So while you are observing that here, x powers are, we are getting the logarithmic values. To remove the logarithmic values, let us assume that x value as 10 power k or something. Okay, na? Then we can find the k value. Okay, right. So we can assume that, and that too we can write this one as x power log x square. Am I right? So in the place of this, we can write that 2 log x base 10, we can write x square. Okay, na? Now I am going to write as x power, x value I can take it as 10 power k. Okay, na? So let us assume that x equals to 10 power k. Okay. Now substitute here. That implies 10 power 5 equals to, in the place of x we can write 10 power k whole to the power of, that means into 3 plus log, in the place of x we can write 10 power k, that means 10 power k square to the base 10. From this 10 power 5 equals to this one. The k square will come front, then log 10 base 10 value will be 1. So from this we can write 10 power k into 3 plus k square. Okay, na? So while you are observing here, the bases are same. Okay, na? The bases, both of the denominators are same. Our bases are same. So we can equate the exponents. So from this we can say that 5 equals to k into 3 plus k square. Okay. So try to simplify this term because it is looking like a quadratic expression. So yeah, sorry. Before that, let us see this x square. I'm trying to writing this one as 2. So like this. Okay, na? then log x value I can write x power 10 power x. So it will be 2k then. I can write this one as 2 log 10 power k to the base 10. Okay, that means 3 plus 2k. It will be 3 plus 2k. Okay, so if the bases are same, we can equate the exponents. From this we can write 5 equals to 3 into k, 3k plus 3 2s are 6k square. So bring all the terms one side, we will get that quadratic equation, that is 6k square plus 3k plus 5, transpose that side becomes minus 5 equals to 0. Now try to identify the factors for this. Minus 5 into 6 minus 30, 5 6 are 30, and identify the factors here. So 10 3s we can take, but 3 should come middle term. So let us try to write the values like 130s, 2 table 15 times, 3 table 10, 4 1 to 5 table 6 times, right? But we are not getting the possible value here. So I'm going to try, I'm going to take it as minus b plus or minus b square minus 4ac format. Yeah, one second here. K into k, 2k square, it is not a 6k square, sorry guys. So it is 2k square. So it will be 2k square plus 3k minus 5 is equal to 0. Then minus 10 factors we should take. Minus 10 we can take 5 2s. 5 into 2, the smaller one if you take minus 5 minus 2, 3. Yes, it is possible now. Now 2k square minus 2k plus 5k minus 5 equals to 0. From the first two terms we can take 2k as a common, then k minus 1 will be remains. From the last two terms 5 common, the k minus 1 will be 0, then k minus 1 equal to 0, nothing but k value 1, or 2k equals to minus 5, k is equals to minus 5 by 2. But what we want the value of x. X is nothing but 10 power k. We have taken that x value is 10 power k. I am writing here. In the place of k, we can write x is equals to 10 power k. That is equals to 10 power k value we got 1. So 10 power 1 is nothing but 10. Our second chance is 10 power minus 5 by 2. So we will have the positive value 10 power 1, nothing but 10. Okay, na? So we will go to the next problem. So let us go to the next problem. Please check. Yeah. The problem number 12. Yeah, that is given that the number of rational terms in the binomial expansion is 4 root 5. The binomial expansion is 4 root 5 plus, where is it? Yeah, 5 root 4 whole to the power of 100. 5 root 4 whole to the power of 100. So rational factor, what is that? Yeah, rational term. Rational term is nothing but the x coefficient must be a positive, or the entire term must be in the form of p by q, not in a irrational format. Because while you are observing this, binomial is a irrational terms. 4 root 5 is an irrational number, 5 root 4 is also an irrational number. While you are expanding this, there is a chance of getting a rational number in between somewhere else. So what is that rational number? That rational term we need to identify. We don't know the rational term. Let us take the rational term with general term, that is t r plus 1 is equals to ncr x power n minus r y power r. We don't know the term, but n value is 100 cr, x is nothing but 4 root 5 whole to the power of 100 minus r, okay, into y value 5 root 4 whole to the power of r. Let us try to convert this. I am going to write it as 4 into 5 power 1 by 2. So this one I am going to write as root 5, I can write as 5 power 1 by 2. Okay, na? Root 2, square root is nothing but whole to the power of 1 by 2, right? Yeah. Into 100 minus r. Here also 5 into root 4. Root 4 is nothing but 2. 5 to 10, 10 power r. Okay, it is already a rational number. But here we have the irrational term here. So let us try to check that irrational term as a positive. Okay, a rational term. So this is nothing but 4 into 5 power this one. I am applying that 4. The exponent is applying separately for 4. 4 is a rational number. So we can write 100 minus r and 5 100 minus r by 2 by using that a power m whole power n formula into 10 power r. Okay, na? So while you are observing this 100 CR, this one 4 power 100 minus r is there, right? 4 power 100 minus r. Here 5 power 100 minus r by 2. But I am trying to write the both of them in the format of same powers. Okay. So for that I am trying to multiply the 4 power s with 2 and divided by 2. Now I am going to write like 4 power 2 into 100 minus r by 2. Can we write like this? 100 minus r, I can write 2 into 100 minus r whole by 2. 2 can be cancelled, the term remains the same. Into 5 power 100 minus r by 2. Now both are having the same denominator. Okay, na? Into 10 power r. Let us try to simplify here small term. That is equals to 100 CR. Yeah. Now if the powers are same, we can multiply the bases. So 4 into 5, 20. Can you take 20? 4 5s. Because powers are same denominator. Okay, let us see the separate way. Let us try to see the separate way. That is equal to 4 power 200 minus 2r by 2 into 5 power 100 minus r by 2. That means both of them we can write into the same square root. Whole to the power of 1 by 2 means into 10 power r. Okay. Now this will be 100 CR. This exponent, while you are observing that exponent must be a rational number. Okay, now that means 4 is a rational number, 5 is a rational number. If their exponent, that means 200 minus 2r by 2 or 100 minus r by 2 value becomes 0 or 1, then the term will be equals to the rational term, or else it will be the irrational term. Okay, now then for that what we have to do? Let us consider this. Okay, yeah, we're getting so much of time here. Yeah, let us check the possibilities once. So if you take here, that means if the numerator is greater than the denominator, it will give the positive term. That means 4 cube, 4 power 5, 4 power 6, like that will come. But the numerator is lesser than the denominator, like 1, -1, -2, that will be irrational term. Am I right? So let us try to check the possibilities of R. The possibilities of R. Yeah, we can take R value is 10 because here 10 powers are there now. So let us try to take R value 1 onwards. Okay, 1, 2, 3, 4 and so on. How many are there? So we can convert them as 10 multiples, right? Because the bases 4 and 5 having the 4 into 5, 20. So let us try to take the 20 multiples. 20 multiples we can take here 20 or 0. 0 we can take. So 0 after 20. So 220 is 40. Next 40, 60, 100. Up to 100 we can take. That means R values can be 0, 20, 40, 60 and 100. How many possibilities are there? 5 possibilities. Yeah, 1, 2, 3, 4. Yeah, 5 possibilities are there. Here also, if you take here also, if you take R value as 0, 100 by 50, a positive number, 20, 40, 60, 100, it is also getting that. Okay, for both of them. Yeah. So, from this, the highest number, number of terms obtained is 6. Okay, na? So, in between 80 also there, no? So, number of terms obtained 6. From the total number of terms here, 101 terms will be there. 101 terms are there. So 101 minus 6 will be 95. So 95 irrational terms are there. Only 6 positive terms. That means rational terms will be there. Okay. So let us go to the next problem. Yeah. Problem number 13. The 13th problem is given that, so the number of terms in the expansion of x plus y plus z, number of terms in the expansion of x plus y plus z whole power n equals to 36. Okay, so we need to find the value of n. So we know already, whenever you are observing that binomial or multinomial, we can identify the number of terms formula or total number of terms formula. So we already discussed in our previous class. So total number of terms equals to n plus k minus 1 c k minus 1. Total number of terms is n plus k minus 1 c k minus 1, where k is nothing but total number of terms in the given polynomial. Here in the term, how many terms in the given polynomial? 3 terms. That means trinomial is given, it is. So n we don't know, but its value is equals to 36 it seems. So in the place of n, we can write only n, and it is 3-termed polynomial, nothing but trinomial. So in the place of k, we have to take 3. 3 minus 1 is 2. 2c2 equals to 36. Okay, na? So n plus 2 c2 actually. N plus 2 into c2 equals to 36. So this one we can write n plus 2 factorial by, like NCR formula. What is NCR formula? N factorial by n minus r factorial into r factorial. Same like n plus 2 factorial by n minus r factorial into r factorial, that is equals to 36. Here minus 2 plus 2 cancel. N plus 2 we can write n plus 2 into n plus 1 into n factorial, where denominator n factorial into 2 factorial, that is equals to 36. These two cancel. Okay, na? So divided by 2 factorial is nothing but 2 itself. So while you are observing that n plus 2 into n plus 1, n plus 2 into n plus 1 equals to 2 transpose that side, 2 into 36 is 72. Now while you are observing, if you take here 7 n value, 7 plus 2 9, 7 plus 1 8. So 9 8s are 72. For satisfying this value, we will get that n value is 7. N value is 7. Okay, na? So if the given multinomial having n power 7, the total number of terms possibilities are 36 terms. Okay, now let us go to the next problem. Yeah, the 14th one, while you are observing that the coefficient of x power 5 in the expansion of 1 plus x whole power 10, 1 plus x whole power 10 by 1 plus 1 by x whole power 20, coefficient of x power 5. So let us try to simplify this one. So 1 plus x whole to the power of 10 into, it is looking like a mixed fraction, right? X 1s are x plus 1 by x whole to the power of 20. That is equals to, while you are observing here, 1 plus x, so x plus 1 both are same terms. Now I am separating the second term as 1 plus x whole power 20 by x power 20. So if the bases are same, we can add the exponents. There is nothing but 1 plus x whole to the power of 30 by x power 20. Okay, na? Right. Now find the coefficient of x power 5. Coefficient of x power 5. So x power 5, let us try to find out that. Yeah. Take the general form tr plus 1 that is equals to ncr x power n minus r into y power r. Okay. But here I am applying that only for the numerator I am taking. Let us try to take the x power 30. Okay, na? So denominator, let us leave it for some time. Then we will find it. Okay. Now n value is 30 cr x power 30 minus r into y. Yeah, or y power r. 1 power r is nothing but 1 only. Okay. That is equals to, while you are observing that, we need to find the value of x power 5. X power 5 coefficient I want. That means this must be 25, because we are already having denominator is 20, x power 20. If you take x power 25, your x power 25 by x power 20 will remain x power 5. We will get that x power 5 coefficient. So that's why this 30 minus r should become 25. Then from this r value is 5. R value is 5. So from that the required answer is 30 cr x power 25. So we want only 30 c5. It is the coefficient. Okay, na? So 30 c5 nothing but 30 into 29 into 28 into 27 26 by 5 into 4 into 3 into 2 into 1. So you can cancel it. After cancelling that, we will get the answer. So 5 4s 20, or else 5 table here 6 times, 6 and here 6 cancel, 4 table here 7 times. Therefore the remaining values are 27, 7 into 27 into 26. So you need to multiply all of them. You will get that x power 5 coefficient. Okay, na? So that is for the 30 c5, or else you can leave it as 30 c5 also. That is depends on the question. Yeah, 30 c5. Option is given in your question. Let us go to the next problem. Yeah, the 15th question is given that x value is 2 plus root 3 whole to the power of n. X value is 2 plus root 3 whole to the power of n. Yeah. And what we need to find? We need to find f equals to x minus greatest integer of x, and f square minus 1 minus f value we need to find. So x minus greatest integer of x we have to find. Then f square value 1 minus f value also we need to find. Okay. Let us see. F is equals to x minus greatest integer of x. So we already previously discussed about the greatest integer function. So let us see that x value in the substitute of 2 plus root 3 minus greatest integer of 2 plus root 3. Okay, na? Whole to the power of n. Okay, let us only find the value of x. Let us find the value of n separately. So we will take only 2 plus root 3 with greatest integer function of 2 plus root 3. So this 2 plus root 3 as it is 2 plus root 3, and whenever you take this root 3 value 1.732 and so on, we can write this greatest integer function as 1.73 is nothing but 3.732 and so on. So greatest integer function only takes the whole part 3. So 2 plus root 3 minus 3. So nothing but root 3 minus 1. This is the value of f. This is the value of f. Now we need to find out that f square by 1 minus f value. F square by 1 minus f value. F square means the given f value, try to apply the square number a plus b whole square formula, a square plus b square minus 2ab. Okay, na? by 1 minus f value is root 3 minus 1. Whenever you have see the minus value becomes root 3 plus 1. So the numerator is 4 minus 2 root 3 by 2 minus root 3. Take 2 common here. 2 minus root 3 by 2 minus root 3. Cancel this value, we got 2. Okay, now let us try to find that n value. Let us take that n value is 2. Let us take that n value is 2. Then it will be x will be 2 plus root 3 whole to the power of 2. So a plus b whole square formula you need to apply. So from that what we have to find? N value only we need to find, right? That means it will give the positive number or even number, even or odd number, non-integer rational number or an odd irrational number. Any one of the answer can be given. For that I am taking that f value is, n value is 2, then x value becomes a square plus b square plus 2ab, that is nothing but 7 plus 4 root 3 I got. X value 7 plus 4 root 3, but we need to find still f value, f square value, or else same you have to apply for that. Again if you do like this, what is the answer you will get? Without knowing that n value, we got something here, answer 2. If you know that n value is 2, let us try to apply the again entire process. Try to do the entire process. You will get that f square by 1 minus f is equal to 12. While you solving entire problem like this by using 7 plus 4 root 3 in the place of x, you will get the value of f square minus f square by 1 minus f value is 12. Nothing but whenever the n value is taken, we are getting the same answer like this. So that is nothing but it gives that n value. Here nothing we have taken means n value 1 we took. Whenever you take n value is 2, we are getting it even number. N value 1 also we are getting the even number. So it is nothing but even function. Okay. So it will give only the even function. So try by using that n value, in the place of x 7 plus 4 root 3 and find that entire process. You will get the answer is f square by 1 minus f is equals to 12. Let us go to the next problem. Yeah, coefficient of a cube plus b power 4 plus c power 5 in the expansion of bc plus ca plus ab. bc plus ca plus ab whole to the power of 6. Which coefficient we need to find here? A cube, b power 4, c power 5. Am I right? Yeah. So let us try to use that multinomial concept. Now I am writing this every time I am going to multiply and divided by a b c whole to the power of 6. That means a into b into c whole to the power of 6. Then it will be 1 by a plus 1 by b plus 1 by c whole to the power of 6. Okay, na? That means for dividing with ABC in the term of entire power of 6, we need to use ABC whole to the power of 6. Then only we are able to divide BC by ABC, CA by ABC, and ABC by ABC. We will get the answer as 1 by A plus 1 by B plus 1 by C. Okay, na? Now what we need to find? We should get that A value, A power 3, B power 4 and C power 5 value we should get. We need to get a cube, b power 4 and c power 5. This value. And for that, so let us take that a power 6 cube means, a power 3 will be right. So from this I am taking that ABC whole to the power of 6, and here 1 by a power 6 will be there, but we want 3 only, a cube, nothing but still a cube will be remains, or 1 by a. Okay. Check here. A power 6 into 1 by a whole cube is nothing but a power 3. Now this one 1 by b whole to the power of 4 I should get. That's why I am taking here 2. That means b power 6 by b power 2 is nothing but b power 4. Now for this 1 by c power 1. So can we write like this? But we have till then a power 6, b power 6, c power 6. But we want a cube, b power 4 and c power 5. I can write like this. Okay now? Now this one I am considering as 1 by a plus 1 by b plus 1 by c. Like a trinomial we can use, right? So let us take this one as this value as x, y, z. Okay now? So x value is 1 by a, y value is 1 by b and z value is 1 by c. And apply the, here whole to the power of 6, this one. Apply the condition like n factorial by p factorial into q factorial into r factorial, a power p, b power q and c power r. This is the format actually. So n is nothing but 6 factorial. Here p is nothing but 3. 3 factorial into 2 factorial into 1 factorial. And a value is nothing but this one 1 by a. Or nothing but a power 3, b power 4 and c power 5. We want this one. So 6 factorial means 6, 5, 4, 3, 2 and 1. 3 factorial is nothing but 3 into 2. 2 factorial means 2 into 1. 1 factorial means 1 1. 3 to 6. Here 2 table, here 2 cancel. 5 4 20, 23 60. This will be the answer. Coefficient here. Okay, now the given format we are converting into our required format like this 1 by a, 1 by b, 1 by c format. From this I am finding this 1 by a value, 1 by b value, 1 by c value by using that 6 power 6. Okay, so let us go to the next problem. 17th one is nothing but 17th one is nothing but if 1 is a integral part of 2 plus root 3 and f is a fractional part. 1 is integral part, f is fractional part. Then we need to find out I plus f into I minus f. So directly you can substitute the value I plus f into I minus f. But the given expansion is 2 plus root 3 whole to the power of n. So this format you already previously we discussed that it will give that n value, means even function will be given. Am I right? Whether it is n value is positive or negative. So directly write like this 2 plus root 3 into 2 minus root 3 whole to the power of n. So a plus b into a minus b format a square minus b square. So 4 minus root 3, a square minus b square means 4 minus 3. 4 minus 3 is nothing but 1, 1 power n is nothing but 1. So the entire answer will give us that answer is 1. Okay now? Now let us go to the 18th problem. If the coefficient of rth term and r plus 1th terms in the expansion of 3 plus 7x power 29 are equal. The 18th question, rth term, r plus 1th term. Okay. Rth term, r plus 1th terms are equal. What is the expansion here? Here it is 3 plus 7x whole to the power of 29. We need to find the value of r. So in the place of third term is 3, 2 plus 1. Same rth term is r. That means r minus 1 plus 1. Okay, no? Like this. R plus 1th term is t r plus 1th term. Okay? Let us apply that. Terms are equal, right? So in the place of r minus 1, so I can take in the place of n format n here x power n minus r 1 y power r format. So n here that is nothing but 29c r minus 1 3 power 29 minus r minus 1 is nothing but plus 1 into y 7x power r minus 1, that is equals to tr plus 1 is nothing but 29 cr plus 1, sorry 29 cr, here r minus 1 I have written, here r I should write. Now 3 power 29 minus r, okay, clear? Now I am going to write this 29, this one n factorial by n minus r factorial into n minus r factorial, yeah, r factorial. So 29 minus r minus 1 is nothing but r plus 1 factorial into r minus 1 factorial. Now this one 3 power 30 minus r, this is 7 into x power r minus 1 is equals to 29 factorial by 29 minus r factorial into r factorial. And this one 3 power 29 minus r into 7x whole to the power of r. So try to bring all the terms one side to find the value of r value. Okay na? Now both sides 29 factorial can be cancelled, numerators. Now this one bring here, that will be 29 minus r factorial into r factorial by 30 minus r factorial into r minus 1 factorial. Okay na? Now these two terms transpose that side, that will be 3 power 29 minus r, here this one 3 power 30 minus r. Same way 7x power r by 7x power r minus 1. Clear? Now 30 minus r I can write, 30 factorial is nothing but 30 factorial into, sorry, 30 into 29 factorial. This one 29 minus r factorial I can write. And this r factorial I can write r into r minus 1 factorial. R minus 1 factorial cancel. These two cancel. What are remaining? R by 30 minus r remains. Okay, this one. A power m by a power n format, a power m minus n. So this will be minus 29 minus 30 is nothing but minus 1. Here minus r plus r can be cancelled. This is 3 power minus 1 only. Now this one 7x whole to the power of r minus r can be cancelled here plus 1. Okay na? So finally we remains r by 30 minus r equals to 3 power minus 1. That is nothing but 1 by 3. So simply 7x by 3 I can write it. Okay na? 7x power 1 no? 3 power minus 1. 3 power 1 minus 1 we can write as 1 by 3. But actually the question is the coefficient is asking, so we can leave that x. So only 7 we can take, 7 by 3. Okay now try to do the cross multiplication. 3 into r, 3r equals to 3 into 30, 210 minus 7r. Minus 7r bring this side plus 7r. 7 plus 3r, 10r equals to 210. R equals to 21. Finished. Let us go to the problem number 19. Find the remainder when 2 power 2000 is divisible by 17. 19th one, 2 power 2000 is divisible by 17. 17 or 7? Yeah, 17. Let us take that nearer value which is closer to the 17 for 2 powers. So we know that 2 power 4 is equals to 16. But we know that congruent rules that A is congruent to B modulo n. I am applying this one, will come easily. That means A minus B exactly divided by n. In same way, 16th minus of 16 is congruent to minus 1 mod 17. That means 16 plus 1 is divided by 17. So 16 is nothing but 2 power 4 is congruent to minus 1 into mod 17. I am raising the powers up to 500 times. This one also 500 times. That means 2 power 2000 equals to minus 1 whole to the power of 500 means becomes plus 1. Plus 1 is modulus 17. That means 1 is the remainder. What is the remainder? 1 is the remainder. Okay. Let us go to the next problem. The coefficient of 2r plus 1th term and 4r plus 1th terms are in the expansion of 1 plus x whole to the power of 10 are equal. Same like previous problem, rth term, r plus 1th terms, how it is equal. So same process we need to apply here also. Try by your own and get it. And the 21st one is, the number of rational terms in the expression. So number of rational terms, how we did, we learned in the previous class. And the last one is the number of expansions of 1 plus 5 root. Both are having the same similar models. Try at your home. So thank you one and all. Have a nice day. Bye bye.